Today on Kaju's Corner, we're going to look at optimization with linear programming. Now, what is linear programming? Well, it's used a lot in business, but it's a method for finding a maximum and minimum values of a function over a given system of inequalities representing a constraint. So basically what we're looking for, we're going to graph some inequalities, and then we're going to have a feasible region. So that's defined by the vertices of the solution set. Now, what happens is with businesses, there are situations that occur in which a company hopes to either maximize their profits or minimize their costs. And many constraints needed to be considered with that, whether it's something like the production costs or the building costs or certain things or how much am I going to sell it for. These issues can often be addressed by using systems of inequalities and linear programming. So we have two types. We have two types of feasible regions. We have our bounded region and we have our unbounded region. So the bounded region there's definite boundaries. You can see by the red dots there, there are vertices. Those red points are their vertices. There could be 3, there could be 4, there could be several more. The unbounded in this example here just means that there's exactly what it sounds. There's no bound to it. There's no end to it. So this is going to keep going. Now, businesses are going to use, obviously, advanced computer programming with this, but we're going to do the best that we can as just graphing by hand. So we'll do a lot more with bounded. Unbounded, we'll just, we'll take a look at it, but we're not going to see that one done so much by hand. So the first thing we're going to look at is a bounded region. So from here, we know we're going to have a maximum and minimum. So we're going to be given a few things. First of all, I'm going to be given some inequalities to graph. So that's this group right here. And then I have to be given a function. I'm going to use that to find my maximum and my minimum. So this one's already graphed for us. So once I graph it, I don't need those inequalities at all. I'm done with those inequalities. Okay, so down the side, I have listed all the vertices that enclose this region. And where did I get this right here? Well, that is the function that's given to me. So now I made a little table to make it a little easier for myself, but you can make your own table or not use a table if you're okay without it. So I'm going to substitute in my value. So I have 4 times -3 minus 2 times 3. So that gives me -12 minus 6, which is -18. Do the same thing for the next one. 4 times 1.5 minus 2 times 3. That gives me 0. And then I have, keep going, 4 times 0 minus 2 times 6, and that gives me -12. And then I have 4 times -2 minus 2 times 6. That gives me -20. Okay, so from here, I'm going to decide, well, my lowest value is right here, my -20, and my highest value is 0. So now how do I write the maximum value and the minimum value? So I need to know two things. I need to know what the value is and what point you used. So my maximum value is 0 at 1.53. My minimum value is -20 at -2.6. Okay, let's look at another one. Okay, as we move to my unbound region, we know I'm going to have a maximum and a minimum, but not both. This is a little bit trickier because we don't know which one I'm not going to have. So we're going to start off the same way. I'm going to graph them, and then I have my function right there that I'm going to use. Now, in this case, I only have 2 points, right? I have a vertex here and a vertex here. I'm going to do the same thing. I'm going to substitute them in. So I have 9 times -4 minus 6 times 0. So that's going to give me -36. And then I have 0. 9 times 0 minus 6 times -6. So that's going to give me +36. So one of them is the maximum. One of them is the minimum. We don't really know. So this is things where it gets a little tough with this unbounded region. Now, just remember in businesses, they're using elaborate programs with computers, so it's much easier for them to tell where a point is and whether it's a maximum or minimum. I like to tell my students that if I think it's really tough for you to figure out as this problem is, I'm just going to let you know if there's a maximum or minimum. So in this case, there is a maximum. So it's a maximum of 36 at 0, -6. Now remember, unbound is going to have a max or a min or a minimum. So in this case, it has a maximum. All right, let's look at our last problem for today. So everything is graphed to make things a little bit easier on time. So this one, I think, if you have trouble seeing this, that y is going to be greater than -6 and less than -2, you can split it. Otherwise, you just know it's between -6 and -2, which is going to be these two lines right there. So there's my graph. My black points are my vertices. So again, I'm going to substitute that in and see how things go. So I have 6 times -4 plus 4 times -6. It gives me -48. And then let me clean that up a little bit. And then my next one, I have 6 times -2 plus 4 times -2. That's -12 and -8. That gives me -20. 6 times 4 plus 4 times -2. That's 24 minus 8. So that gives me 16. And my last one, I have 6 times 8 plus 4 times -6. That's 48 minus 24. That gives me 24. So let's say my highest value here is 24. My lowest value is 48. So my maximum value is going to be 24 at the point 8, -6. And my minimum value is going to be -48 at -4, -6. Okay, great job. You have a good day. Bye.